Okay, cool. So awesome. So I can't believe it's October. These meetups that so happen to land where the first Thursdays on the first always throw me off a bit. But I'm glad we've got two awesome talks lined up for tonight, and really excited to hear both of them. We have Shane Mitchell. He's going to be speaking about security, application security in PHP. And we've also got Justin Yost, who's going to be speaking tonight about just interacting with PHP and databases. So that was by request at the last meetup. So two awesome talks, two awesome speakers. Appreciate you guys reaching out and offering to speak. At the end of the meetup, we can try and figure out two more talks for the November meetup. Don't have anything lined up yet for that, so we got to figure that out. But just to touch base a little bit about our sponsors and some of the cool prizes we'll be giving away here at the end of the meetup. We have, first off, just to mention them, Tech Systems. They've been a longtime sponsor. They're a recruiter pretty much across the nation, but specifically here in Vegas, they've been very supportive. Jessica over there, who's kind of our rep, she reached out to me about two opportunities here in Vegas. I would highly encourage you guys to reach out to her. Her email is on the meetup page. But if you are interested, there's two positions that are open right now that they're actively looking for developers. One's a 6-month contract to hire opportunity that's 100% remote. In this day and age, remote's becoming a bigger and bigger thing. And this company, they have bunch of different things that they're working with, so it's going to be a little bit wider range of frameworks. They're working with Zen framework, Laravel, Symfony. They need somebody with backend LAMP experience. They deal with MySQL. So if you are interested in that, definitely reach out to her. And there's also William Hill, who has been actively looking as well for experienced developers. They're looking mainly for a Laravel developer. So if you are interested, definitely reach out to her and she can give you more details on that. Definitely, I can't give away the first company, but from what I can hear, what she's told me, both of these companies have good teams, good benefits, and things like that. Well, the first one's a contract to hire, but after they have good benefits. But a lot of companies now are kind of doing that to make sure things pan out with the developer before actually going through with hiring. But huge shout out to Tech Systems. Thanks again for them sponsoring our meetups. Although they're not hooking us up with food and drink, they're basically continuing to be a supporter for us and sponsoring our meetup.com costs and things like that. So big shout out to them. We also have JetBrains. They're a great company that develops awesome IDEs. And we'll be giving away a 1-year PHP Storm license here at the end of the meetup to one lucky winner. And we've also got SymphonyCast. They previously were known as KMP University, but since have been acquired by Symfony, since they were kind of really focused on Symfony, but honestly, they have a lot of tracks on JavaScript and other things surrounding web development. So we'll be giving away a 1-month license for them as well. So again, shout out to them. Hopefully, by next year, we can be meeting in person again at the Innovation Center, but I'm sure, when things do calm down, we'll be able to figure that out. But as of now, these meetups are probably going to be remote for quite some time. But glad we still can get together like this and, share our knowledge and our experiences. So I believe I've touched base on everything I wanted to shout out. So I will now hand off the baton to let's go with you, Shane, first, because I'm not sure. I think Justin's still trying to figure out his microphone thing.
Not a problem.
Yeah, I'm testing it. I'm testing it all.
Sounds better. So.
Yeah, that sounded good.
I think I got it all working.
Yeah, sounds awesome. It's better. Got the Rode microphone there, huh? Nice. Cool. All right. Well, yeah.
Whoever wants to go first, I'm cool.
Yeah.
Shane, if you want to
flip a coin.
Sure. You said my name first, so let me get this going really quick. Oops.
And also just a quick note, tonight's meetup, it looks like the recording is working for me on this one. So if you do know somebody who would benefit from these talks, definitely send out our YouTube channel, trying to post each meetup there. So if for some reason you don't catch a full thing, or you know somebody who would benefit from the talks, definitely send the video their way.
All right. Oops, hold on. I got to put it on the right slide first. I go back a slide.
Beautiful.
There we go.
All right, I'm going to mute myself.
All right. Well, and with that, hello, everyone. Good evening. Thanks for joining us today for this talk. Today, we're going to talk about some of the little things that are commonly overlooked when creating basically any software application. From my experience, most application vulnerabilities don't really exist because the developer doesn't know how to resolve it, but rather isn't given or taking the time to do so. Tonight's presentation isn't going to teach you how to become a PHP security expert or anything like that, but what it will do for most of you, hopefully, is get you to think about those little things in your day-to-day tasks, which is going to be the best way to stay secure in your application. And by doing this, which, believe it or not, actually takes a lot less time than you may think, you'll be surprised with how many little things you'll catch before your product gets released into the hands of your users. So a little bit about myself first. My name is Shane Mitchell. I'm currently the application security architect at Boyd Gaming. I'm also the co-organizer of the PHP Vegas meetup and of the Las Vegas chapter of OWASP and the OWASP meetup. Currently the father of two wonderful children who really do inspire me to do my best all the time. I don't really do any of the social media things or any of that really, so I don't have like a Twitter or anything you can follow, unfortunately, but you can always email me at any time, and I'm always happy to help out if anybody ever has questions or needs advice. You know, I found my brain works in a very logical fashion, which is why programming always appealed to me. And from the first time I wrote a line of code at high school, I knew that's what I was going to be doing for a living. So, you know, I've spent years being that guy that all my friends, you know, asked to fix their computers and stuff. I'm sure I'm not the only one. But now I've worked professionally in development for about a decade now, and I've learned a lot of valuable things in that amount of time. I've been lucky enough to work in vastly different industries, which provide a lot of opportunity and experience in extremely different concepts and designs and implementations. It's funny how different industries have completely different tendencies, even when it comes to the way their software applications are built, the way their development processes work, and everything. And it's given me a lot of insight and a lot of weird ways that I didn't expect to get, you know, when I progressed through my journey of, you know, being a developer. You know, I've been handed a lot of projects and just told, fix it. It's very common. And, you know, most of them I thought was that they just need to be completely rewritten. But, you know, some of them are all right. You know, some of them actually still make me cringe a little when I think about them today, but, you know, it's all in the experience, right? What I have learned from countless hours of debugging was more often than not each little issue is probably not that big of a deal if it were the only issue. But most of the time, it's a collection of little missed things. Something was rushed, someone got a little lazy here, or just didn't realize that, not adjusting this one little thing to be meeting best practice was really going to end up making a difference in the end. It's those little bad ideas, I guess, that are stacked upon each other over and over again, which really result in the vulnerability in your application being exploited and resulting in a really costly fix. So I've talked with tons of developers in my career from all different backgrounds and experience levels. From my experience, even the most novice developers can identify a basic potential security issue, I guess, when asked to look for one. The problem isn't really that they can't see that it's a security issue. The problem is that's not really how the process works in the real world when we're actually building things. Instead, we're told to focus on writing business logic and making pretty interfaces because that's what the people who pay the checks care about. That's the business, right? That's how they work. And then it's justified to an extent, but the business creates and drives these processes that the developers must follow and focuses on the items that will directly make them money, because that's the bread and butter. That's what allows you to be a developer. But there's always going to be another deadline. Our jobs as developers and system architects is to ensure that we're, protecting that pretty interface with a rock solid logic and make sure that it's not held together by, I guess, digital or proverbial duct tape. You don't want to just slap a bunch of things together and throw it out there and expect it to just have a long-lived life that, we want our creation to grow and expand and become great. To do this, it's important not to rush, to follow industry standards and best practices and take the time to ask all the little questions and document those questions and their answers. Like what libraries are that component using that I want to add in my application just to help make it easier on me to do X functionality. Where are the dependent library, or any of those dependent libraries marked for deprecation? When's the last time that they had been updated or maintained? And then more importantly, when is the last time you checked? Because things change very fast. And your questions your questions have to be relevant to the task at hand. But just because you checked 2 or 3 weeks ago or 2 or 3 months ago doesn't necessarily mean things haven't changed. You have to build that into your process. Your process is there to guide and help you make sure you ask the right questions. When's the last time you looked for an alternative component? What little things that you might not think about, that you might need to ask questions about. What ports and protocols are you intending to use that might conflict with other traffic on that network? What's the standard for a certain type of implementation, and have you verified that library or component or that your developers are meeting that standard? And when's the last time you checked at what best practice is for that and what the standard is, right? Are you even aware of the up-to-date standards? They often change, and it really should become part of your normal process to really look into things as frequently as you need to make sure that you're up to date for each project that comes across your plate. Everyone works differently, but it's important to develop a good process that works for you so you can ensure that you thoroughly review the details. The results in finding, I guess, those little things you would not have caught simply because you took the time to look. These are often the little things that that alone don't really compromise your system necessarily. But as you'll see later in the presentation, they quickly add up, and when you're not careful, you'll have a lot more to deal with than you can really handle. And by paying attention to those little things, you're building a good, secure foundation. So, you're not throwing together a feature. You're building a foundation for a feature suite. You're not just making it work. Plus, I found that having something documented on paper for someone to read, for some reason, helps push the business into agreeing with things. I've come to the same person 2 different times with the same argument, but with one time writing down sources of information, and it got approved the second time. So that you have to kind of think about who you're working with, and do what it takes to make sure your application is secure. You got to work it into your process too. One thing that's often relied upon to assist with all those little things, because let's be honest, it is a lot of little things, are frameworks. Many frameworks exist. Some of them are purpose-built frameworks like Magento or something, or you might have very generic frameworks that allow you to kind of do whatever you want, like Laravel or WordPress. They might even have a kitchen sink hidden in there somewhere. These are great tools. I strongly encourage they be used when the occasion calls for it. They provide a great groundwork for your application, and a well-maintained framework will have several maintainers that ensure that it follows industry best practices and standards and stays up to date with new patches and new expectations in security exploits and things of that nature. A framework really is basically just an abstraction layer which creates structured APIs to interact with underlying components that you need to interact with, that each provide little specialized functionalities. Some of those components might be third-party libraries used by the framework and not actually built into the framework. This is done, for several reasons, but most of the time, most notably, it just offloads that functionality that's already been created elsewhere by people that have spent a lot more time becoming experts on that situation or technology, hopefully. And that means that the framework only has to integrate with an API, the library's API, instead of really creating and maintaining a whole feature and all the things that come along with it, which is a great thing. There's a lot of great, well-maintained libraries for various things that you might find yourself needing to do when you're writing code. Unlike frameworks, libraries are often used in small little scripts as well, because they focus on those small specialized functionalities and often grow over time to support a wide scope of use cases in that specific functionality. This makes it very robust, often a lot more secure, and literally battle tested. And in doing that, you're inherently finding all the security flaws and bugs, which does make them great for using them as a component in your framework or in a script, because they keep everything updated and you're confident with the maintainers, and it saves you time. Why wouldn't you use it? Once you learn how to use a framework really well, it's easy to find yourself finding ways to just make the tool work for the job. You know what I mean? Instead of finding the right tool, or just thinking about what other thing might work better, because, I already know it. It'll be fast. Boom, boom, boom. While they're great, there's really 2 important things to consider when you do use a framework, because they do support more functionality than you might use that might cause, unused or potential blind spots by these unused components, because you're not using the functionality. You're not worried about the library because it's not being actively handled in your code. However, if for some reason someone finds a way through another component to access that component lying dormant and it's not updated, well, there you go. And again, that's that combination of little things that really does affect you in the end. It's really a good idea to get a good handle on the framework's components as early on in the life of the project as possible. You want to make sure you understand the framework which your application is built on, because it is going to be the guiding and limiting, the number one most guiding and limiting factor of your application. It's not something that only needs to be done once, because again, vulnerabilities arise constantly. Though you're not using that component, you might still need to make sure it's updated, or completely disabled or removed, or what cleaned up. Make sure you're appropriately handling the situation. The second thing to consider really is that the whole framework needs to be updated. All the components frequently need to be updated when you need to make sure that you need to really make sure that your software development lifecycle, your whole process, your team process needs to facilitate framework updates on a regular basis. I've worked at places very, very often where whatever framework that application is built with is going to be the life of that application, and that's just the way it is. Everything was thrown together. Everything was brittle. There was no way to even handle something like that. It would just be as loose of a deployment to upgrade the framework as it would be to change a piece of text on an HTML file. It's you got to make sure you're ready to really maintain your framework properly in a production environment. When you're creating an application, that has all those components, you probably want to make sure you find a good fitting framework, because again, there's many frameworks. A lot of them are purpose-built. A lot of them are very lightweight. Really pay attention to the components of that framework use and make sure that is the right framework for you. Not just the framework, but again, the components that it uses are very important to keeping your application secure. But what if you're, not writing some huge application? You might just be writing some little script. They're a lot more simple. There's a lot less reason for concern about vulnerabilities or anything, right? Believe it or not, I actually catch more direct security violations with the complacent use of little scripts than I do with most applications and code deployment requests. These scripts are everywhere, right? Everybody uses them for everything. They perform all sorts of little things, from deployment automations to site scraping to automating some configuration task that you don't want to have to do every time you have to help set up a new junior devs box, or some report that someone asked for you that they won't give you time to build a proper thing to create the report, so you just threw some script together. These are common things that we do, but we get real complacent with these scripts. These little remedial tasks take time, and we save ourselves a lot of time. We still need to be kind of careful. They're not full-fledged applications, but because of that, there's rarely, if not almost never, documented procedures for the running or the handling, the maintenance, the location, who should be accessing it, what that application script, or what application that script, or in any resource really, it has credentials in there for to access. Is that calling some API? And that script has your admin AWS account key in there because you were trying to automate some thing that would come back and return the health status of these this highly volatile EC2 cluster. You got something, whatever it is. There's tons of reasons for having these little scripts and complacently putting very sensitive information in them. It does leave breathing room from all the processes, which is why they're so valuable and so used, but they really do pose a security risk. Unlike frameworks, you really don't have to worry as much about dependencies, though sometimes your script may have them. You really have to worry about, again, being careful about what's in that script and where you're leaving that script. What output is that script outputting, and how many copies of that do you have just lying around, right? You can't. It's hard. It's easy to get complacent with that stuff. You really have to start asking yourselves questions again, go back to that process. Start diving down to the little things. Ask yourself questions that you may assume you already know the answer, but take the time to do it. Does your script access these resources or systems? Does it need authentication? Just go through the questions, and make sure you follow your process every time. It's very common, from my experience anyways, for the scripts to have to be initialized by a human implementer, but that's not always the case, right? Most of the time that's the case, but I've definitely done, I don't know what you call it, script stacking a little bit, where I've piggybacked other scripts that I've written with other scripts, and things can get real bad real fast if you're not careful. I know there's a lot of deployment scripts and things like that. Excuse me. A lot of deployment scripts and things like that, which are launched by, some system call or webhook. That a lot of those deployment scripts have credentials in them as well. I found that, because these scripts are written for easing that day-to-day task, like gathering reports, like I said, all that stuff. Your dev, I'm sorry, I got lost in my notes for a second there. But anyway, be careful with your credentials in your scripts. It's very difficult to control, the creation of scripts in your environment. Your devs, we're always going to be having these ad hoc needs like this. You want to make sure that you control the output of your scripts. You let your team create the scripts, but you provide a process in which they can ensure to do so securely and properly. The number one way anybody gets compromised is through some sort of human error, social interaction, or something like that. Just because your developer's box has authentication so that they can access it doesn't mean they should have, free reign all the time with everything. You still have to you got to think about the little things, right? If your script authenticates with like a database, which please don't do that. What you might want to do is, reference an environment variable or something like that. Prompt for an input. That's probably the best way you should do it. If you're running a script, it's probably interactive, and use that. Prompt for an input. It's only a couple extra lines of code. You can do so securely. It really does help things in the end, because all it needs is one file to get compromised that has some vulnerabilities or that has some credentials in it, and then what they'll do is they'll do what's called credential hopping. They'll start hopping around, scanning what they can get access to with one set of credentials, and then how many other credentials they can get from that, and start just doing that a whole bunch over and over until they can figure out, oh, well, now I have access to this system that I think is valuable or whatever, right? Now I can go ahead and deploy my ransomware. So you really got to, be careful with scripts laying around. I've seen it happen a whole bunch of times to developers when I'm reviewing things, and I'm like, yeah, I've seen scripts, I've seen Excel files that are meant to create financial reports that the front desk person had on their computer even, and it had production HR database, it had production gaming stuff on there. It's easy to get complacent with this stuff. I'm sorry if I'm driving it in a little bit, but I see this a lot, and I just want to make sure that, we think about these little things, right? So when you're really trying to stay ahead of the game and try to make your application secure, I mentioned earlier that you want to really frequently look into the latest information that's available for any project, right? Part of that is knowing what sources you can trust, where you should look for what information, and what is the industry standard and best practice for these situations, right? When you're looking for a reputable source for community-driven content on application security specifically, OWASP is what you're looking for. OWASP, or the Open Web Application Security Project, is an online community that provides freely available articles, methodologies, documentation tools, and technologies in the field of web application security. It was founded in like 2001. It really is widely recognized throughout the information security industry as the go-to reference for layer 7 security or application level security. For those of you who don't know what layer 7, layer 7 of the OSI model is the application layer. Like I said, if you've never heard of the Open Systems Interconnection model, I urge you to look into that. It's commonly referred to as the OSI model, and there's 7 layers of the OSI model, with the application layer being at the very top and the physical layer being at the very bottom. And OWASP is full of amazing resources pertaining to application security. One of my favorites is actually the OWASP cheat sheet, cheatsheetseries.owasp.org. I love this thing. Everything from AJAX security to XML security. It's got an alphabetized reference. You can download it from their homepage even. It's a really awesome tool. And actually, I wouldn't mind trying to show you this really quick. The OWASP cheat sheet is, again, it's a great tool. Go to the alphabetical index. It kind of helps. They have tons and tons of information. And every time I'm in here, I learn something new. I love this thing. It's a great resource. You know, I like cheat sheets in general, but this one is probably my number one. Again, I think I learn something every time I go through here. Even I come in here looking for specific things, and I'll end up finding myself clicking through, learning about something else. There's actually a PHP configuration section in here. Where is it? Stop scrolling, funny. There we go. This is great. It's not much there, but there are things that are very commonly overlooked as not really important. But these are also, again, great examples of those little things I mentioned that you just want to make sure you're aware of. For example, it suggests the PHP's default configuration for session name. Excuse me. It suggests changing, the default session name configuration. When one day you find your users are getting their sessions hijacked, so you follow the trail back to the actual vulnerability, and you find out that it was exploited only because the application knows what the default PHP session name key was. Otherwise, they couldn't have exploited anything, and your users would have been fine. These are the little things that actually are in real life the most often how your system is going to be compromised. While that vulnerability would be there, whether you change the default or not, there's still 2 things that would remain true. The best practice is not to use any manufacturer defaults in a production system, right? Like, we should be changing all those little things. Whenever it's a production system, we take our time, go through each configuration and make sure that we're secure and have everything the way we're going to need it for our application usage. Then the number 2 thing, if the configuration had been updated during provisioning, you would have probably not been exploited in the first place, right? So just follow best practices. Again, I found that it's more common than you think when a new vulnerability gets identified, that it's only exploitable because of some default configuration. I mean, it happens very frequently. One good example of that is like the Mongo database one, right? That got a MongoDB got a bad rap because admins weren't changing the default admin password or disabling the admin account in general and creating other user accounts that are specific to what's needed. Right? The admins weren't following best practices to a mass degree, and it gave a product a bad name, which, it's really not Mongo's fault. So I decided to actually click a random topic in that cheat sheet, and I just to learn something to put in there, and I randomly clicked on clickjacking defense. I found that there are a few good ways to prevent or mitigate clickjacking, and I thought that was actually relevant to PHP development, since we're most often web applications and websites and things of that nature anyways. For those of you who don't know what clickjacking is, I guess, it's basically when an attacker essentially uses like an opaque layer above an interactable item, like a anchor tag or a HTTP link or a button or image, to essentially hijack the click, right? Because you're not interacting with what they have. You're putting your invisible layer in front of it. It's really, really the best way to mitigate that is actually with properly designed CSS styles. You might not think that your CSS would really provide so much or be such a cause of security concern, but it really is. Even your front-end developers should be going to secure code training and making sure they're up to date on all the new little things. So front-end developers use Flash. Flash is going deprecated by the end of the year. No browser will support Flash by 2021. But it's still probably used by some front-end developers who don't realize that because they're not staying up to date on things. You can also use JavaScript and event frame ancestors, I think something like that. Frame ancestors, I believe it was, to then kind of detect when someone's trying to do clickjacking or trying to create the opaque layer, and yeah, it gets real tricky at that point. But really, the best way is proper CSS. There's sections in there for Docker security, Ajax security, LDAP injection, OS command injection defense. Even you find yourself wanting to get more into security, there's a whole section on threat modeling. I actually read through that thing twice because I thought it was it was a good direction for me coming from development to moving into the security side of things. It really kind of took my perspective on things. So again, if you're really interested in the security side of things, take a look at it. It's OWASP is a great thing. It's an amazing resource. I highly recommend anybody check it out and frequent the resources. The cheat sheet is great. Again, sorry. But here's where I start to get into some more specific examples about those little things that are often overlooked. They can add up quickly, and they're things that we likely all encounter frequently, like logging. Let's use logging for example, right? Applications perform complex logic, and there are many individual pieces of data flowing around in memory at any given time. It is best practice to be verbose in your logging. So you want to be verbose in your logging. You want that visibility for troubleshooting. You want to know what your application is doing. But I have seen logs be the source of system compromise. Log levels are a great thing for keeping logged data organized and for logging different information in various environments. But using wrong log levels or just simply logging info level on your production server or just dumping everything into logs all the time can really expose critical components of your application or even your users' information, depending on what the application does and what data is flowing through it. Debug and info level logs often dump full objects in some frameworks, which will really help for troubleshooting, but it, again, could contain sensitive information like credentials. You have an error that you gracefully handled in your production application, but because it gracefully logged all of this full object dump of your AWS SDK, now it contains your whole, again, your admin credentials or whatever credentials to this production EC2 system or whatever it is, right? And that's not good. Your logs shouldn't have that information. That you should, this config file, key should be the reference, not the value. So pay attention to the way you log, due diligence, again, follow best practice and have proper logging levels in your right environments. If someone's able to somehow gain visibility into the log store, which is really commonly just a simple file, they can get a lot more information than they should have. Depending on how your application works, you also may face a much worse issue. I've had to look into an issue with log file size spike. Oh, yeah. And our monitoring tools kind of alerted us of this. And the company had just acquired this application not too long ago. It was like a month into having this application. And there were no protections against what IPs could SSH into the server. And they set very weak credentials. And by the way, don't use the top level domain of your application as the admin password, please. Please don't do that. That was the case in this instance. I think my jaw literally dropped with that one. But this is what the attacker did. So first, the attacker tracked the server IP from the DNS, and it worked because there were no load balancers or firewalls or WAFs or anything to protect. Just anyone could SSH to the server from anywhere. And then they guessed admin and used the top level domain as the password. Apparently, it only took their 15th attempt. They guessed some things like password and admin, and apparently their script or whatever they did was very efficient. This was only possible because there were no protections against brute force attacks or any of that. 15 attempts even. That's very good. I give them that. That's very good as far as getting in. But they shouldn't even have gotten 15 attempts. There should have been 3 attempts and you're locked out of that of SSH into that account or something, right? Like, you need to have your proper protections in place, right? So, but then they poked around for, I think it was about 8 minutes before they just started dumping logs. And then that's when things, really started to get messy a little bit, Now they had access to the logs. They knew what framework was being used. They knew a lot of other information that can be deduced from poking around in a file system. I would like to note that this application did not have an environment variables file, but if it would have had one, it probably would have been just as easy for the attacker because he had admin access. And the attacker then changed the value of some environment variables, and because the application, it's PHP, the application, the request comes in, spins up the application process, request looks at the environment variables. It's the way the process flow works. They were able to change the environment variables, and then apparently, I guess they were seeing the environment variables dumped in the logs, so they were trying to test some stuff, and that caused monitoring. That's what really caused the monitoring tools to notice. But again, that's a monitoring tool, so it didn't happen. I didn't even get alerted for a few minutes afterwards because it has to make sure that it's not a weird anomaly. We didn't have really well-written monitoring tools on this application, really. And in that 5 minutes from the time they really started doing damage, for me to get alerted and get in there, they managed to dump, a lot of information, system information, all kinds of access credentials, the live users credentials. Luckily, we didn't have any social security numbers or credit cards or anything like that. But it's still not good for your company's reputation to have to go to your users and tell them, hey, sorry, someone just got a hold of your email address and your account password. So hopefully you didn't use the same password on your email account. So really, it was because the increased log size is why our monitoring tools even found it. If they were cleaning it up each time, we probably wouldn't even have noticed. I ended up forcing a shutdown of the server. I put up a quick 404 page, and it actually was a couple hours while we figured out the issue and fixed it. So though we were only down for it was about 2 hours, we had to spend about 25 hours worth of work just to fix and get everything locked down again because of all the information that I found in that log file that guy was reading, or that person, sorry, was reading. Databases, API keys, all kinds of things. This required multiple spots of downtime for various servers, for little things to be reconfigured while they got fixed, Again, it was about 25 hours worth of work just to go and review and adjust things from that breach that really wasn't even bad, really, right? Because logs are how we're able to debug, audit things, and in general gain visibility into the snapshots of the data states within your application. They're a large target to gain insight into how your application can be exploited further. This particular instance, luckily, again, didn't result in any direct loss of revenue, but that's actually rarely the case, and we did get fairly lucky with which of our systems that was attempted with, to be honest. It also really kind of stinks, again, spending the next few weeks monitoring all the various assets, hoping that someone hasn't gained unauthorized access or something. One thing that this incident did do, actually, was give me the ammunition to tell my boss that we need to do thorough security scans of the system. While my intent was to hire someone, of course, as soon as I got my boss to agree, finally, that meant I have to do the extra work, So, what do you know? But that's actually where I really started getting interested in the security side of things, and when I found the OWASP ZAP tool. It's, again, another awesome OWASP tool. You should really check it out. And I realized how lax I'd been about security. Implementing security scans on production systems at a minimum will not take a ton of time, and there are free options out there, implementing and running the first set of scans on a production system took me about 7 hours total. And that was being super thorough and having my first time going through the process. And it would have showed us the issues before we were taken advantage of. And it was actually, I don't remember what the cost was, because I didn't end up going with a free tool, but yeah, it was well worth, it would have been well worth the money. 7 hours would have saved 25 hours of work that we had just, and we would have just done it in the first place. So if the average PHP developer today makes about $50 to $60 an hour, which means about $420 initial investment cost, at $7, that would have saved from a $1,500 expense for 25 hours of work to then go through and recorrect everything, right? So that's a number that you can show. Again, throwing that documentation out there, showing that proof, saying, hey, look at this is what it is. If you're signing off on it, cool. Otherwise, I told you, right? Follow your process, CYA, I guess, right? Another fun one is actually a PHP specific one, and one of the reasons why I don't like XML. The other one's Microsoft, but that's another story. Through directly exploiting the XML RPC decode function in an early release of PHP 7.2, That's how our application was exploited. And we had to parse some daily financial reports from a vendor. They were building an API still. So they were XML documents. They were placed on a file share through FTPS. I was going to ask whether anybody knows the difference between FTPS and SFTP, but it looks like I'm hogging a lot of time here. I had a lot to go, so I'll skip that. But anyways, because the vendor was actively building the API to retrieve this information, we only expected to parse the XML for about 4 to 6 weeks. Some malicious person somehow got access to their system and got a hold of their FTP servers and added invalid characters to the file. Coincidentally, this was a system with a custom framework that was configured to use the Zen allocation or use Zen ALLOC environment variable. This actually was the same me attempting to update the previous application. This is actually the same application being exposed. They were troubleshooting memory leaks, and they had this setting configured. I didn't realize it, and what this environment variable does is it stops the memory manager from functioning all the way, which it explained why we were seeing such high memory usage, and that allows the memory allocations to fall back on the default system allocators, and it's only really useful for debugging like memory leaks. But they had it on. Don't leave it on in production unless you really need to, and then turn it off again, right? Don't be lazy, turn it back off. I think there was a comment above it that said, this doesn't matter because we have a large hard drive. So because the schedule job was poorly written to call itself upon a failure, I had one of my junior devs write the worker task, and it just I didn't realize that it had that loop in there, so it just kept refetching and refetching, and that's how we ended up noticing. Once we noticed, I pulled the file. I was unable to open it in Notepad++. Well, I was able to open it, I guess. I didn't. I saw invalid characters in there. They were actually some bytecode injection meant for you to open an Excel file. So apparently they went through and they just started doing injection to every file that had a .csv or .ex the Excel extension, and was throwing this bytecode in there, hoping that some business would open it with Excel, and bam, they got a hold of something, right? And they did it to this vendor system, and we were kind of affected by proxy, and not even directly. It would just happen to be our system going crazy and crashing because of this. Some outside interference caused some misconfiguration in our system to cause our system to go down, which is a vulnerability. But what's out there today, right? While sharing examples of things that I've experienced will help hopefully think about those little things, I'd also like to, help give examples of at least something that's current, right? That you should watch out for. So very often Nginx is used in coordination with php-fpm to serve up your application. If you have a PHP application, sorry. I've had quite a few applications set up this way. At one point, one of my production servers was set up with this same exact configuration set that I'm displaying right here. Apparently, so many people did, and were reposting this same set of configurations in the same order that somebody saw an opportunity. They noticed the regex in the fast split path info directive can be broken down using the new line character encoded from %0a. Broken regex leads to an empty path info environment variable, which triggers the bug. This issue leads to code execution. Later in the code, the value of path info 0 is set to 0, then fcgi put in v is called. Using a carefully chosen length of the URL path and a query string, an attacker can make a precise path info point to feed into that first byte of the FCGI data segs structure. Putting a 0 moves it that character position field backwards, and it overwrites some data, and then basically you have a fake PHP value FCGI. I keep saying that wrong. Sorry, variable, and it uses a chain of carefully chosen config values to get that code executed. Basically, in the end, I think it was $A equals and then the value. And if you really structure the URI right after exposing the bug, anything after that A is code that would be processed by the PHP interpreter directly. So yeah, that's not a good thing. Something to watch out for. If you have Nginx running your php-fpm application, you go double check, make sure you don't have this configured probably, or make sure your framework is properly protecting against it. Because technically it's not even a PHP bug. This is a bug in the regex parsing in Nginx, in this version of Nginx. I'm not sure if Nginx has put a fix out for that one yet. But honestly, PHP itself is pretty secure. And the vulnerabilities that do exist really aren't usually that easy to exploit if best practices are used. I think there's a whole bunch of, or like 10 or so vulnerabilities on the exif PHP extension, which is used for like reading image metadata. If you're like pulling an image and you're trying to read image metadata, the name and other parts of the image, it's really commonly used for that. And apparently there's a whole bunch of vulnerabilities for buffer overflows that would cause, information disclosure potentially, or system crash. They'd have to have access to your system for the information disclosure. But really, this slide, it looks like I'm stealing a lot of time here. This slide, I was going into a little bit more specifics on CVEs, and that stands for common vulnerabilities and exposures. And it's a term that's created by the MITRE Corporation and controls kind of the official CVE library, and it's funded by the National Security Cyber Division of the U.S. Department of Homeland Security. Really, these are meant to create a standard for identifying, rating, and interfacing and coordinating with other companies with what vulnerabilities and exploits and exposures are out there. So definitely go check out, if you haven't been exposed to CVEs, definitely go check out MITRE.org, or you can go to cve.mitre.org, and you can see a lot of, you can go and search for CVEs, go review a lot of CVEs. It's the official CVE library. Myself, I really like cvedetails.com. I think the interface is much better. They got the vulnerability rating of.
Recording is on.
Hey, sorry about that. Something.
No problem.
I do have a question real quick about the monitoring tools, because I guess without you being alerted about the logs freaking out, you would have never caught wind of that in time, right? So are there did you guys roll your own for kind of monitoring that stuff, or are there tools out there, specifically I guess Linux, that can monitor that kind of stuff? Because to be honest, even personally, there was a system that I ran into that ran out of disk space. Some kind of noob stuff. I know I probably need to have something that kind of monitors that stuff, but I don't want to write my own stuff. I imagine there's something out there, but I'm not sure.
There's a ton of tools. There's free tools. I can't really. honestly, I can't really think of the names of any of the free ones offhand, but I know there's free monitoring tools out there that do basic things like memory usage alerting. Like you can set, I saw one free one that you could set if your memory usage is above what percent for X amount of time, send an email, SMS, or whatever. But then you have to configure the SMS integration, the email integration. You know what I mean. So there's a lot of work involved still, but there's still some cool ones out there. The more robust ones, obviously, you'll have to pay for, and those are the ones that are really gonna notice things like, hey, we saw somebody authenticated from an IP outside of a normal IP range that would authenticate with your server. Boom, alert, right? That kind of thing. Those are the ones that I would definitely suggest to use because, but they cost money, right? Though the thing about those tools, the reason why I suggest those so much, having a paid one, is most of the attackers or people that are out there trying to exploit your system, they're piggybacking off of stuff that other people that have experienced are giving them. A lot of the little things that you doing, like the basics, are going to catch are the people poking around who are trying to figuring out the lay of the land and figuring out what they're doing, and you know what I mean. The vast majority of people that are going to be attacking your system are going to be using a little bit more sophisticated things that a lot of the free tools in monitoring aren't really gonna effectively handle. And later, I start to talk about. Well, I was just talking about web application firewalls. It's a perfect segue, actually. Did that answer your question, kind of? I'm sorry, I couldn't give like a specific.
No. Yeah, it's fine. Yeah,
okay.
Great talk so far.
Yeah, thanks. And so it's a good segue actually into like a WAF, or a web application firewalls. Most people think firewalls, and they think the networking guy is saying TCP, UDP allowed through these ports, and that's what they think, right? But the WAFs, or web application firewalls, it's basically like a front door to your application. What it does is it's so like, if you think of it like a front door, you can have a very basic configuration. You have a basic door. Someone has to turn a handle to get in. There's a door there. Someone has to perform an action to be able to get through the door. There's one component, right? But you can add a lock to that handle. You can add a deadbolt. You can put a chain on there. You can add layers, right? You can add layers of security on there before you can even get into your application to start seeing what your application will respond with. They control the inbound and outbound flow of your traffic. Your DNS or your domain is actually pointed at the web application firewall, not at your application. It is a proxy to your application. There are some good free ones, but again, like I just told Josh, this falls into that same boat. These are not going to be nearly as robust. Mod security. So the three free ones I have on here are, I specifically chose these free ones because mod security has a paid option, and from my understanding is a pretty good free WAF. However, IronBee was created by the creators of mod security to be a free for all open sourced WAF. So, same creators, paid version versus not paid version. But the creators for both of those products were really good. And then if you have a Nginx specific, if your application is served by Nginx, Noxy is compatible with all Nginx versions. It actually stands for Nginx Anti-CSS and SQL Injection. So it's not nearly as robust as like F5 or Cisco or Cloudflare is going to be, right? But in that regards, AWS charges you for a WAF, which is great. You have it built in your cloud. You already have something in AWS. You configure AWS. You put a bunch of WAF configurations in there. It's great. But a lot of those really high-end components, like F5 and Cisco and Cloudflare, they have AI that are looking for anomalous patterns of requests, even if it is the same ports and the same kind of source IP and things like that. They look for a lot of things like that. They'll do deep pack inspection, and although TLS 1.3 might throw a wrench in that for a lot of these guys, they do again deep pack inspection, and they do they have the ability, even if your traffic is encrypted, to be able to log the actual payload of encrypted traffic. So going with the paid options are you get the bang for the buck in this field, I guess is what I'm trying to say. And then I have to reiterate that the key to getting and staying secure and making sure your application is as secure as it can be is by staying informed. You have to do this by finding reliable resources and referencing them often. Again, OWASP is a great resource. Another plug on the cheat sheet, because I love that thing. There's even that PHP configuration section. If you're just looking at PHP specific things, but your application deals with technologies, and that is a good resource for the vulnerabilities in the technologies and protocols themselves that your application uses, which is, again, a great resource. You always stay up to date on the latest vulnerabilities affecting the components and frameworks that your application relies upon. Again, CVE Details is a great resource. They actually have the ability to search by the vendor and product on that website. So I would actually, let me see if I can. So Laravel, right? Here's some CVEs for Laravel. Laravel specific vulnerabilities. They have PHP, WordPress, Node.js, PHP specific vulnerabilities, right? I love this tool because it's easy to use. It's fast. There's lots of different ways you can search. You see the CVE. It gives you a brief explanation. You get a score to know how risky that vulnerability is. You might see something like this. Okay, well, that's not worth the 3 weeks of re-architecting my system to worry about. What ways can we mitigate it instead of just outright patch the vulnerability, right? Versus this, okay, well, you get a 7.5 or a 10. Okay, well, we need to address that right away. I don't want that being in my ecosystem for more than it has to be, right? There's a lot of great resources. The Paragon Initiative. This one is a blog site, but I saw there's a lot of good resources links in there. It's actually a software consulting and web dev shop that they focus on security, but they have a good blog content in there, and this is a great resource. And I'll share a lot of the resources links after the talk. Another good one is the awesome PHP security GitHub repo. Plug on that one. I think I've seen that one more than once being mentioned as a good resource in this meetup. So again, it is a great resource. And PHP security. Read the docs. Just read the docs. It's all you can really do in the end. And then that's it. I appreciate everybody for listening to my talk and to listen to me go on. And are there any questions?
A lot to go over there. Yeah, this could have been probably a workshop.
I tried to, I was trying to not to get too far into detail, because there's a lot with your application security, and I wanted to give some aspects of PHP specifically, but really the number one thing I can drive into making sure your application is secure is your process. That is the number one thing, because if your process is to make sure you're reviewing those little things. The better your process facilitates you verifying those little things every time, because there's a lot of them. That's why that's why they slip through the cracks, is they're like little marbles. You can't hold them all. You want to try to hold as many of them as you can. Make that process as tight of a weave as you can to hold all those marbles, right?
For sure. Yeah, no, I wrote down a bunch of stuff here. I've already downloaded the Zap tool, so I'm going to try to bring down my production servers now. I appreciate you sharing all of this with us, man. It was a great talk. I'm really impressed.
Yeah, thank you.
Awesome. Anybody else have questions for Shane?
No questions, but I would like to thank you for the lecture. It's my first time in the meetup group, so.
Yeah, well, welcome, and thank you for getting a lot out of it. That's what I do it for.
Thank you, I appreciate it.
Good deal. All right, well, let's hand things over to Justin for our next talk. He's going to be speaking about PHP and database access. Kind of more of a talk that we had, or a request that we had last meetup. Somebody just wanted to know, kind of the ways to connect a database without all the fancy stuff. So, this is going to be a talk. Maybe for some senior developers, they might know some stuff that's already in here, but I'm sure we might catch something new here and there. But definitely for anybody new with PHP, you'll want to know how this stuff works at this level. So this will be a good talk. Justin, are you ready?
I'm ready, Josh.
All right, sweet.
I'm ready. Hey, everyone. Let me know if someone can't see my screen. You should see databases and PHP on the screen. So yeah, like Josh said, I can talk. Like Josh said, my name is Justin Yost. I'm an engineering manager at Wirecutter. If you don't know about Wirecutter, we're owned by the New York Times, and we provide recommendations for you to find the best stuff for you to live your best life. So anything from beds and mattresses to USB cables to air purifiers to refrigerators to baking pans, basically anything and everything. So if you're trying to find something to buy, take a look, and then you'll keep me employed, which is always good for all of us. I'll also add Wirecutter is hiring for a fair number of positions across the board for software engineers. We do PHP development. We also do a lot of React, JavaScript. So we're hiring some engineers across the board there, as well as we have several other positions that we're trying to fill. In particular, I'm hiring a lead DevOps engineer on my team. So if you have someone who you know who has a lot of DevOps engineering experience, have them reach out to me. So for this project, I didn't want us to like go in and do something with like Docker per se, or like go in with a bunch of other stuff. So if you wanted to try just installing without having to figure out like trying to use Homebrew or trying to figure out anything else, if you just wanted to try like, hey, I want to just like install a thing. So there's this amps.com. So what amps is this is the really basic, just like I want to install Apache, MySQL, PHP, Perl, Python, some other stuff, like just basically on my computer without having to think about it at all, right? So like this is just a pure like, I just want to get up and running as fast as possible. If that's your goal, you should go with something like this. This is pretty easy to install and use. So yeah, if you're looking for something a little bit different, for some reason the links aren't working. It is Sprint Cube Docker. If you're looking for something a little more modern, a little more modern web development, something that you might use in an actual, real work environment. A lot of teams now are using like Docker. Here's an actual Docker box, so you can build this sort of stuff up, and it provides a basic LAMP stack. So that's Linux, Apache, MySQL, PHP, etc. However, if you want to do something where you want to try using, and you want to go ahead and use a framework, and you want to get started with something, you can use in Laravel. They have a project called Homestead. As part of this Homestead project, you can install it, and it'll install all of this associated software with it. And you can use it with Laravel. You can also use it with other tools as well. You don't have to use it with Laravel. So you can install it with different projects and such. So those are kind of some different ways for just like, I just want to provide some brief little like, hey, I don't have any of this. I don't even know how to get started. Where should I look at? Here's kind of your three options. And we're kind of going from I just want to install this stuff raw on my machine to I want to do something that's like a little more modern web development approach, or I want to do something and I want to get something built in with a ton of tooling, and I want to possibly have the ability to drop into a framework if I want to. Those are kind of your three options there. So once we have it running, we should be able to do php-v to see that PHP is running. Here we can see I have PHP 7.4.7 installed. You can see I have it available. That's all that we really need. And we'll check that I have MySQL with MySQL -- version. And there I have version 8.0. I'm running this. You'll notice I installed MySQL and I installed PHP just using Homebrew. So this is installed just right up on my Mac OS 10 machine. So now that I've got these, let's view a database. So here's what I did. We're going to have this connect and close class, or not class, file. We're requiring once just a db vars.php. I made this to just like reduce our workload in needing to not include this everywhere. I'm just defining these as constants in PHP. So this defines this as a constant. You'd probably, again, going off of the last talk, it'd be better for these to be environment variables, but this was just kind of like the quick and dirty way of doing this. You notice, right, we're still keeping this isolated. So I have all these other projects and files along the side, but I only need them defined once. So I have a database that I'm defining, MySQL, a database host, local host, a username, root, a password, which is empty, and a database name, basics. This local host and root, so when I installed MySQL on my machine, this is what it set it up with. I didn't try adding in a username. I didn't try adding a password. I just went with the bare minimum default setup. So this is just like plain Jane out of the box what I got. For your setup, it's probably going to look a little bit different. It probably should include a username and a password. But again, this is only on my local machine, so I'm just trying this out. Okay, so no classes, no nothing. No namespaces, no nothing else. All I have is a couple of functions, and I execute those functions. I have an open basic connection function. That open basic connection creates a new instance of this MySQL I object. This MySQL I thing is our wrapper in PHP to be able to talk to MySQL. We pass it a host name, a username, a password, and the database name that we're going to connect to. We call new on that. That gives us a connection thing. This connection thing, if it has a connect error value here, then we had some sort of error connecting to it. If we didn't, we connected successfully. Then I just return the connection. So I'm back here on line 21. I just return the connection and I close the basic connection with connection close. So all I'm doing here is I'm just opening the connection and then closing it. And let's make sure that that works. So PHP, connect and close. Connection successful. Short, sweet, and simple. So that's all that it really looks like. This is literally about the shortest and simplest way that you could get PHP talking to a MySQL instance. There are several other drivers for this as well. There's several other classes to do this work. So if you want to talk to MS SQL or SQLite, there's variations on this as well. I just figured I'd show the MySQL one because that's the most standard one, and it pretty much matches up probably with what most anyone is probably doing. So let's actually see what happens, for instance, if I have an error. So let's say I change the DB username to something completely random. Now if I try to connect, I get a bunch of errors because something went wrong. Access denied for user. Yeah, here you can see there's the error. PHP warning MySQL construct, access denied for user. So I got an access denied, and then it all kind of fails across. So you can see, totally works. And when it fails in a pretty obvious way. All right. So now I want to just connect. Oh, no, that was exactly what it was. Close. Oh, no, view. Yeah. Connect, read, and close. So this time, I want to read from the database. This time, I do the exact same stuff, right? Notice I require that DB vars. I have that open basic connection method. I have the close basic connection. The only thing different here is I have these couple of lines. So I create a connection query. So here I'm calling this query method on this. And I say select star from notes limit 5. And then I returned X number of rows. And then I can var dump each of those rows. And then I can close the result. So the result is the actual response back that I get from the database here. Let's try that out. You can see here some rows. You can see I've got a bunch of, here's one row, right? It's got an ID of 1. It's got a big long text string, and it's got a title. So I just did 3 simple fields in this database. Here's an ID, here's a string, here's a title. And you can see. Notice this query is just a simple query. Like it's just raw SQL. I can plug whatever I want into this. I don't have to do anything fancy. There's nothing complicated. You'll note this row when I var dump it, it's just an array, right? So I could access these as array elements. So I could access this as, I could var dump row, but I could also echo row ID as well. So if I want to do that, you'll see there's that row ID, there's that row ID right there. Pretty simple, right? Connection query lets me access this and be able to talk to this as, and I can pass in, whatever SQL I want to pass in. Yeah, that's all that looks like. That's pretty easy. Okay, what about I want to write something? Now, this is probably the part that's trickier, right? Because now, okay, connecting is easy. Closing the connection, obviously super easy, right? Reading is pretty easy, and reading makes a lot of sense, right? Like you're reading a lot of stuff from the database, but writing is really where like you care the most, right? You want to be sure that you're making your writes correctly. You want to be sure you're passing your data in properly. You want to be sure everything's coming in through. It's also, if you want to do stuff where you want to be able to create the database through these SQL commands, you'll have to do these write operations. What does that one look like? Well, it actually looks pretty similar. So again, I require once my DB vars, I open the basic connection, I close the basic connection. So here, I open the basic connection. Again, all I'm doing is just using that query operation again. I don't do anything actually all that different. I simply say insert into, and I have my insert into statement. So notes with a text and a title, I have a value. This is a new note, Let's change this up a little bit just so we're sure. This note, we'll say brand new. Okay. So now we should be able to see a new note inserted into that with that text field. We'll say that we have that print, that row was inserted successfully, and then we're going to query back again, and we're going to get all the notes again, ordered by ID, descending limit 5. And I'm going to, we're going to printf it again. We're going to loop over the results, close the result, and then close the basic connection again. You can see there's our note that there's the note. There's that brand new note that we inserted. All the way at the top, since we got that row inserted, select return 5 rows. And you can see there's that brand new note. The reason we got it all the way up the top, of course, is because we told this to order by ID descending. So it's going to return the results in with the ID, with the biggest ID at the top. You'll note here, so a couple of things. Here, since this result is an insert, we don't have to close the result. That result just is the result, right? This query operation, because it's an insert operation, doesn't really return anything. So this result is basically a null, more or less. There's nothing really here that we can do anything with. But here, because this result actually returns results, it actually returns something from the database. We have stuff that we can loop over and do stuff with. So we have to close this. This is just to like make sure that we're closing our connections to the database. We don't want to keep this stuff open and like have a bunch of open connections to the database. You can cause all kinds of weird stuff if you try writing a bunch of times to the database and then you never close the connection. The database is going to be sitting there and asking, basically waiting for that connection. Like it thinks that connection is going to be sending it more data. So we want to close the results, close the connections to ensure that the database and all of our PHP objects and everything along the chain understands that, no, I'm not talking to this database any longer. I don't need these results any longer. You can do whatever you want with that stuff. This is actually pretty important, especially if you're doing this, like on kind of cheap hosting, or maybe you're doing this on a really small like test project on a small AWS, one of the micro instances or something along those lines. They have pretty low limits on the number of connections that you can have open. So if you're, say, running a website and you get, more than 100 people hitting your database all at once, and you're on some small little cheap site, if you keep all those connections open, and then those 100 people go in and 100 new people come back inside of, say, like the next minute or so, there's now 200 connections to your database because you didn't close out those other 100 some odd connections. They're still sitting around. They're still waiting to be ready to talk to the database. And that could obviously cause a lot of problems, again, especially if you're on some of these smaller hosting plans or some of these like, free services in some of these other ways. So that was MySQL-i. MySQL-i, it creates a connection to the MySQL database that you can use in PHP. It has some procedural patterns. I didn't want to show the procedural patterns just because I don't think they're used all that frequently anymore. And in all honesty, if you're even looking at MySQL-i, you should probably grab the object-oriented patterns. Now, MySQL-i, it will create a connection, and you can run those SQL commands. I mean, you saw that. It is not a good way to connect to a database. The reason we don't use tools like MySQL-i in our databases, or the reason we don't use MySQL-i in our frameworks anymore, is because it's just not a very useful, and elegant sort of tool. It's really complicated. You'll note there's a couple of things with this. One, you'll note this can only talk to MySQL directly, right? So if I need to swap this out, where I need to say, hey, I really want to talk to this type of database, I need to talk to a SQLite database. Like I'm building a framework like Laravel or any of these other frameworks, Magento, WordPress, where I need to be able to talk to different types of databases under the hood. You could see how the code would get really complicated and really confusing. You'll also note there's no real abstraction layer here. It's just taking in raw SQL. So if I need to modify this for any reason, there's not a really good way to do this. It also has a problem here of, for instance, you have to insert your values that you want to add or do for finds directly into the query itself. There's no good way to do a prepared statement. We'll talk about that a little bit, but there's a real security risk with those prepared statements or not using prepared statements. Yeah. Instead, PHP built this tool called PDO. It stands for PHP Database Object. It gives you a consistent interface that enables you to connect to a variety of databases using a single pattern. So the real leg up in using something like PDO versus MySQLi is PDO gives you the ability to talk to a MySQL database, talk to an MS SQL database, talk to a SQLite database, talk to an Oracle database, talk to a whatever database using the same interface. One of the other issues with using something like MySQLi is it's not even the same command, and they have different results from those commands. So for MySQLi, it's query, but maybe for the SQLite, it's actually like execute. So that function that you have to use here, it's not just like, oh, we have to swap in something and we have to like form a different connection or pass this back, but it may not even use the same function or method against that connection object to even run a simple query. For PDO, it instead provides that one single interface. So in PDO, if this was going to talk to a SQLite database versus some other database, it would still be operating off of the exact same, whatever its query method was. It also then gives you a standard interface for doing things like, I want to get the number of rows. I want to deal with whatever a connection error was, all that sort of stuff. PDO really is the choice that you should be making if you're trying to connect to a database. If you're doing anything with raw PHP or you're doing anything at that level where you're not using a framework, you really should not be using MySQLi. I just want to show it off just so you have an understanding of like, okay, what is literally the simplest thing that I could be doing if I want to connect to a database. There's other abstraction. There's other similar sort of tools, like I said, for talking to some of these other databases. However, one advantage that PDO also has, it includes drivers to enable you to talk to more databases than just MySQL, MS SQL, Postgres, SQLite. Like I said, it can talk to IBM databases, can talk to Oracle, it can talk to Fox, Trod, I can't remember what it is, Fox something database. So if you're in the situation where you're needing to be able to talk to, some random database out there, there may not actually be a standard out of the box, here's the PHP class to be able to enable you to do this work. However, more likely, there are drivers for PDO to drive that particular database layer. They also have this same data access abstraction layer that I kind of talked a little bit about. This means you have the same PDO function to connect, to run a statement, return results, all that sort of stuff. This really gives you that ability then to be able to do this thing where you can do this hot swapping, where you can say, hey, I'm dealing with MySQL, but now I want to test it against MS SQL, or I want to test it against Postgres SQL, or I want to test it against SQLite. This also gives you a really good advantage to be able to say like, hey, I want to try testing out a couple of different databases and see which one works best for me. Or maybe I need to do something where I want to be able to say, hey, I need to talk to this database in this case, but now I need to talk to this other database. Say you're building a tool that has to talk to two different databases for some reason or the other. I mean, it's certainly not an uncommon scenario. Something like PDO gives you the ability to have this abstraction layer. So you're still writing the same code, but you can instead say, hey, this is my MySQL PDO connection object versus this is my Postgres QL connection object. However, one thing that PDO does not do, and this is where you have something like a framework can really help you out, it doesn't abstract away the differences in the actual query language or the engine. So what do I mean by that? what I mean by that is when you have something like MySQL versus MS SQL versus Postgres versus SQLite, they all operate off of, they all use SQL under the hood, right? Like there's an actual query language. And there are standards for that query language. So they all kind of operate in similar sorts of ways. However, they all operate slightly differently. And each of them have like different values or parameters or different ways that you can set things up. So for instance, MySQL has the ability to do things like window functions and views. PostgreSQL has an ability to write functions. SQLite doesn't have anything for really like high levels of abstractions of different types of fields. It basically has just like a text field, it has an integer field, and like a Boolean field. And that's it has a couple other fields, other types of fields other than that. But that's basically the types of columns that you can have for a SQLite database, which means if you try saying like, hey, I want to create a long text blob field in SQLite's going to throw at you and be like, I don't even understand what you're trying to do. Whereas MySQL will understand like, yes, I can create a long blob field. That sort of stuff that is an actual difference. Or again, if you're trying to create something where in MySQL you want to create a view, MySQL has views, whereas PostgreSQL doesn't really have views. It has instead this concept of like functions. So like those differences in the actual query language or that engine layer are not abstracted away. The only thing that is abstracted away is the actual logic that you write to connect and execute your statements and do your return your results and process those results for each of those different databases. That's what's abstracted away. So what does PDO look like when we want to connect? It looks pretty similar. So again, we have this DB vars. So again, this DB vars file, same thing as before. This time we're going to use this database constant, which we're going to have set as MySQL. We create a thing called the DSN connection string. This DSN is a connection string that we create. This connection string defines our database. So MySQL :DB name, we pass in the database name, the host. You would also pass in, if you wanted to set some options, for instance, you could set, some different options for saying, I want to be parsing and returning results in UTF-8. I want to do whatever your options might be. I want to have a limit on the size of the results that can be returned. Those types of options would get set also here in this connection string. So you create that connection string. You'll notice this connection string is now abstracted out, right? Because I could swap out this database and say that I'm connecting to a MySQL versus a SQLite versus whatever else. And the only thing that would change in this string, assuming the name and the host was all the same, would be that database, right? So this is part of how we're building in this abstraction ability. We pass in the username, we pass in the password, and we call a new PDO instance. That PDO connection is there. You'll note now we have this get code and get message, right? So it just throws an exception if it's not able to connect, right? You're seeing how this is getting now a little more PHP standard, and it's feeling a little bit more simpler and straightforward. We have the connection successful, we close the PDO connection, and then to close the connection, we just unset it because this is now like a true PHP object. So since it's a PHP object, we can just unset the variable and that closes the connection. So let's try that. But you'll see connection was successful. Now this time, if we go to DB vars and again, change that up, change the username. And this time you'll see here, notice this connection error is now much easier to understand. We get an actual message here. We get this 1045. We get an actual message here. We get that it was access denied using password no, right? This now becomes much clearer to us exactly what happened in this connection error, right? So it's not just that this PDO abstraction layer makes it easier for us to swap between stuff. It's also giving us this much cleaner interface and much easier to debug and triage exactly what's happening, as opposed to this jumble of mess that we have to read through and parse and like try figuring out, wait, I got an undefined variable here, I got getting a property here, I got this, I got that, I got the other, right? This is now much, much easier to read and understand and like be able to grasp exactly what's going on. We'll swap that back to root. All right, so let's connect, read, and close. Again, this is going to look pretty similar to what you expected. We require once against the DB vars. We again open our PDO connection. We close our PDO connection much like you expect. And here, the only difference is we're going to create a statement. So a PDO connection query statement, and that returns an array. So as row, and then we can just var dump the row. So we can just loop over it and var dump out the results. And there you'll see, we get our results. Everything looks pretty straightforward. You'll note, however, there's a couple of differences here. You note we get both them as an array here and then as a 0, or an ID here and then the thing here, right? String. That reason is because for PDO, we have the option to return things as, we can return them either just as a straight array, where we're just returning each of them as keys, or we return them as index. So basically indexed as if they don't have an actual index, they're indexed with a numeric, or we can index them with the actual value of the field, the column that the data is stored in. So PDO is already giving us kind of this ability to like have an idea of how we want to return our results and how we want to process this stuff. You also know, right, that this feels somewhat similar to how the MySQL stuff works, right? But again, it's a little bit simpler. It's a little bit more straightforward. It's a little bit easier to understand like what's happening and what's occurring. So let's write and see what that looks like. So here I have a write operation. So again, open, close. Here I open the connection, right? Here I'm going to create an insert into. So insert into notes, text title. Notice here what I'm doing. I have this values, and then I have colon text, colon title. Now what I do is this is called a prepared statement. What a prepared statement lets me do is it lets me set up a statement in which I'm going to then replace these values at runtime. One of the benefits of this PDO step is these values will then be completely safe. What I mean here is that if I had a user who decided to be funny and decided to do something like, if you've seen the XKCD thing of like Bobby drop tables, where essentially someone's trying to do a SQL injection on you. They're trying to break your site by injecting some special piece of code, some special piece of SQL that is going to cause your database to be broken or to cause something to break. This completely nullifies that. You don't have to think about it. You don't have to care about it. You don't have to do any sort of work on your side. You can just take the user input and pass it straight through. That's hugely beneficial. So let's see how that works. So I create my statement. I prepare my statement. Notice I need this colon and then the name of the key that I'm going to set in the data for. I have my prepared statement. I execute it by saying I'm going to set the text and the title to these fields, right? So again, just doing this as an array. And then I fetch all. And then here, what I'm doing is I'm grabbing my last insert ID. So this fetch all is taking my prepared statement, getting any results out of it, right? This PDO connection is getting the last insert ID. So this is saying, hey, what was the last thing that I inserted into the database? Get that ID. Here, Then I'm just going to rerun my read operation. So I'm going to select all from notes, order by ID, so on and so forth. So let's try that. So if I scroll, oops. Yeah. So there's my last thing that I created. Oh, nope, there it is. Sorry. Scrolled a little too far. So you can see there's my last insert ID. That's string 13. So there's that last insert ID. There's that result. Results an empty array, which makes sense. And then there's the one that I inserted right here. And we can double check that this is the one that I inserted. Let's change this. This is a brand new PDO text. If I run this one more time, we should see 14 with this is a brand new PDO text. And you can see there's that last insert ID. And then again, just close the PDO connection by unsetting it, and I'm done. So these prepared statements enable you to create statements that have these placeholders. You can use either that colon name style or a question mark style. The question mark I really don't like. So just to demonstrate what that question mark looks like, it looks like that, and then you execute it like that. So this being your whatever the first question mark is, that being the second question mark, that's really ugly. For one good reason, you have to remember the exact order that things are in, right? The other problem is, I mean, this is very easy to tell, like, you know, we have array keys, right? But also, you can swap these orders. And it doesn't matter. Because it's just an array. It's a keyed array. So I can swap that. And it doesn't complain, right? My text is still brand new PDO text. And my title is still, this is a PDO title, regardless of how I swap that order, right? So it makes your execute portion of this code like much easier to read and much easier to understand. And especially, I mean, you could envision this where if you're doing an insert operation that has, you know, more than just even a couple handful of values that you're needing to insert, your execute statement would get really confusing and really complicated pretty quickly. You can technically mix and match. You cannot mix and match the style of placeholders. Therefore, again, just go with the name style and it's going to make your life a lot easier. So this enables you to bind that user input to that placeholder. And again, it just prevents that possibility of user input breaking your statements in any way. You don't need to quote the placeholder. You don't need to do anything with it. Just drop it in and PDO is going to figure it all out. It's incredibly good at this and it's extremely well tested. So if you want to go beyond this, which you probably do, like this really is literally like the simplest sort of logic for PHP and talking to a database. There's a thing called ORMs. ORMs are what frameworks use. They are an object relational mapping. What they enable you to do is to be able to map a database table or an entry in a database table, so a single row or the whole database table itself. So you have a table of notes. It can map that notes table to an object, a PHP object notes, and it could possibly even map that each row of notes to a single object note. And then it enables you to be able to write logic in which you don't ever have to actually see the SQL. You never actually interact with, or you don't need to interact with the actual underlying SQL to be able to do these read write operations. It gives you a whole other level of abstraction. The benefits here is PDO minimizes those differences in executing that raw SQL against a database engine. However, that ORM minimizes the differences in the actual SQL variant used in the database engine. So PDO enables you to say, hey, I can talk to pretty much any database engine, and I don't have to like understand exactly what's occurring. The ORM enables you to say, well, I don't even want to learn SQL if I don't have to, or I don't want to write SQL if I don't need to, because maybe for the vast majority of stuff that I'm doing, I don't actually need to know or understand like an exact SQL statement, like especially for things like selects and inserts and those sorts of operations. Maybe you need to know it for some really complex piece of code that you're writing, but in general, you probably don't need to know SQL. And in fact, in my, day-to-day job, like generally speaking, like almost all of our code in the data and the stuff that I work with and against like doesn't write a lot of raw SQL. There's very little raw SQL. Most of it again is using these frameworks and these ORMs and these other abilities to like provide these abstraction layers. And those abstraction layers are just giving you the ability to do this sort of work without having to like, what happens if someone does this in lowercase, and does it make a difference, and which way do I have to have the things, and do I need to have a notes dot text here, or do I need something here or something here, right? Like it just makes your life way easier. If you go with pretty much any framework these days, they all have some level of an ORM. And there's many of the frameworks also enable you to use the ORM without using the full framework. So if you just want to play around with the different ORMs, most frameworks give you the ability to do that. There's also many ORMs that are like framework agnostic, in which there are ORMs out there that you can just like install an ORM and use it if you want to try doing it in a pretty minimal way. There's the talk. I'm on Twitter, probably too much. I'm on GitHub, probably not enough anymore. My personal site, which probably hasn't been updated in several years. I also have a bunch of courses on LinkedIn Learning. So if you enjoyed listening to me ramble for 40 minutes, you can watch there. And I'm going to stop sharing.
Nice one. Oh, the joys of connecting to a database. You didn't even get into the fun stuff like indexing and sharding and crashing your database.
This was not a database. This was a connect PHP and databases. Like
at first, when I saw MySQLi, I was just like, "Isn't that like deprecated?" But then I was thinking, that's the MySQL extension, right?
Yeah, it's the MySQL extension, so it's technically not deprecated. I don't know if they're ever planning on.
I think MySQLi, it stands for MySQL improved, right? But
yeah. So it's the
about it.
yeah, the old MySQL without the I is deprecated, and like isn't, because it's super shitty, and like you shouldn't use it, and it has tons of security holes and whatnot. So yeah.
Right.
Hey, I did my first PHP project in my SQLi, and just a huge procedure project to build a login system. And then I started, learning more about frameworks, and then got into Laravel later on. But yeah, I agree with you. It's just too complicated, and there's a bunch of server configuration that you got to do and some hacking around to make it work. So yeah, I appreciate the lecture about it, too. So
yeah, no problem.
Thank you.
And like, I mean, many of us started just like hacking around on this stuff and doing whatever was like the easiest or the simplest. So I think it's always good to like show like, here's the easy, here's like the raw, like what is the simplest way that I can get started, and then like show like the path towards doing something, in a better way, or an approach that, why does this simple way like not scale up very effectively? Like what's the downsides of it?
Yeah, when you were giving the lecture, I kind of had a flashback. Oh my God, the first time I actually touched PDO, and I'm like, oh my God, did this thing exist? Really? But yeah, I started from scratch a long time ago, and just digging around. So use PDO, yeah.